Hello, STEM Nation. Jeff here, and welcome to episode number 25 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math to help guide students interested in STEM careers. If you like what you hear on this podcast, I ask that you please share it with a friend. Now let's get fired up with our guest, Tom, and I hope our chat will help ignite your passion towards a STEM career. Tom earned an electrical engineering degree from Michigan State, a master's in electrical engineering from the Georgia Institute of Technology, and most recently, his Apple iOS development certificate from DevMountain. He is currently a senior iOS engineer at Move. Welcome to the show, Tom. Fill in any gaps and share a bit of your personal life.
Thanks, Jeff. I'm glad to be here for sure, talking with you. From a personal side, I grew up in Michigan. You mentioned I went to Michigan State for my undergrad, so went to Michigan State and pursued electrical engineering, which was, at the time that was where I wanted to go. I loved electrical engineering in the physics course that I took as a senior in high school. And so I started heading down that route when I went to college at Michigan State, moved to North Carolina, lived there for a while, went up to Wisconsin, lived there for a while as an electrical engineer, and then started kind of working on some software engineering on my free time and decided to head over to DevMountain in Salt Lake City. And now I'm out here in Silicon Valley working with Move Inc. on their iPhone app. So it's been an interesting ride so far, but I'm definitely happy with the path that I've taken with STEM.
All right, thanks, Tom, for that overview, and let's dig right in here. So you do have a pretty extensive background in electrical engineering, a lot of work experience, and then you started, kind of delving into the software side and decided to go to, towards iOS app development. What are some career opportunities that you saw that led you down the iOS app development realm, and did your EE background prove beneficial in that path?
Yeah, there's actually quite a few different routes that you can take as an iOS developer. And, the most common one is to go look for there's companies all over the place that have iPhone apps, right? We all have an iPhone in our pocket. Obviously there's Android users out there too, and they have Android developers for their phones. But for mobile development in general, we all have a smartphone in our pockets. So each one of those smartphones is running software, and any of the apps that we can all think of that we use every single day, those are all the different types of opportunities that are out there. All those companies are, they're not always looking for engineers all the time, but chances are, a good percentage of them are looking for a good mobile developer.
Tom, do you need a 4-year degree, or can you just get out of high school and go to, let's say, DevMountain and learn how to do iOS apps?
Yeah, so that's something that's a big question right now with these coding boot camps, right? Because they're relatively new. They've only been around a few years. And you'll see a lot of people that are very skeptical about the coding boot camps because their claim is that they can teach somebody with little to no programming experience all the skills and traits that they need to go and pursue a software engineering role in as little as 12 weeks, right? So there are definitely a lot of skeptics out there. And what I will say about it is that a coding boot camp is what you make of it. When I went to DevMountain, it was part of a plan for me. I decided to switch from electrical engineering and start moving towards software engineering, which isn't that big of a leap, There's a lot that translates from electrical engineering to software engineering. At a coding boot camp, if you put in the hours and you work really hard, you have to work really hard before the coding boot camp too, because when you show up to DevMountain, they expect you to be ready to hit the ground running. They expect you to have learned the Swift programming language to a reasonable degree to where you can understand what people are talking about when they're talking about different functions that are available in the programming language, things like that. I think if you're coming out of high school and you're thinking about a coding boot camp like DevMountain, it's reasonable to think that you could go straight to DevMountain and learn the skills that you need and go pursue a career in iOS development. Or, I mean, DevMountain has web development courses and QA courses as well. So yeah, I don't think a 4-year degree is required, but at the same time, I'll also say that I'm really happy I have my 4-year degree from Michigan State. You know, some of the courses that are seen as non-technical, or maybe they don't translate directly to the degree I was pursuing when I was there, it does end up helping in the end, you know, because some of the underrated skills of successful engineers that I've seen are gained through some of those courses that we may not think of as the courses that you really need to be professional in the STEM fields. I mean, it could be a writing course, an English course, it could be some kind of social science course. Those things translate in the professional world because you need to be able to communicate your ideas with other professionals, other colleagues. And you need to be able to take something that's really complicated technically and understand how to break it down for somebody that doesn't know what you've been working on for the past couple of weeks. And so I still think that an undergraduate degree is something that's very beneficial in the professional world.
Yeah, and I tend to agree with that, Tom. I think you learn a lot of skills. For one, STEM curriculums, they teach you how to solve problems. Doesn't matter what kind of problem it is. So you high school students in STEM Nation out there that are thinking of going to, let's say, just a software boot camp, you'll learn how to program software, but you will miss out on some of the other aspects of problem-solving skills. And if you want to set yourself apart from everybody else going to a boot camp, you know, there's 4-year degrees that you can go to that are just more general engineering that'll set you up to go off to a 12-week software boot camp and set you for life. So think about that long and hard before you graduate high school and think about what you really want to do. And you can always pick up Android development, iOS development on your own in high school, download the tools and start playing with it and see if that's really what you want to do. So Tom, we're going to get really specific here. And what is your area of specific expertise?
So my area of specific expertise right now, I would say it's just iOS development in general. You know, there's I'm working on an app right now, Realtor.com, that has a lot of iOS concepts in it, but I wouldn't say that it's not specialized towards game development or anything specific like that. It's kind of general iOS app development.
And what would a typical workday look like for you?
So a typical workday, you know, I get in the morning, get my coffee going, sit down, and I usually like to open up a blog and take a look at that and try to learn a new skill, learn a new concept like that as much as I can. You know, engineering is one of those things where there are a lot of different ways that you can differentiate yourself from the next engineer. And one of the ways that I try to do that is I try to keep reading and keep learning every single day. So I like to open up with a blog or some kind of technical note or something like that that can teach me a new idea or concept. From there, I'll kind of start moving towards the work that I'm actually assigned at the time. And the thing with engineering is that it literally does change every single day. You know, there's always brand new problems popping up. Some of them take 2 months, some of them take 2 years, some of them take 2 days. And so if it's something short, you know, maybe it's something that I work on that morning and I'm able to wrap it up and send it out for a review. So another something common you'll see in the engineering world is different layers or different levels in a hierarchy of engineers at a company, where you'll have more junior engineers, you'll have senior engineers, and you'll have some maybe staff engineers, where any work that's done at one of the lower levels needs to work its way up through the chain, up to the higher levels like the staff engineer, to be reviewed. So send that type of stuff out. And we have a lot of meetings too. You know, it's a good sized company where we need to collaborate a lot to achieve the goals that we want to achieve. So we'll have some meetings throughout the day where we're discussing a new idea or concept, maybe discussing something bad that popped up. You never know. It changes every day. So there's a lot of collaboration that goes on. It kind of follows that type of a pattern, but like I say, it changes every day, and you never really know what to expect in STEM.
Yeah, I agree with that, Tom. STEM Nation, the jobs out there with STEM, they're always dynamic, which keeps the jobs interesting. There's always something new to learn. So if you enjoy learning, you enjoy a dynamic environment, STEM is a very good career path.
Yeah, I agree.
So Tom, we're gonna get fired up here. And what is one thing that really has you fired up in the app development space?
Right now, it's game development, but I'll say for the future, I think it's augmented reality. So in the iOS world and mobile apps or mobile development world in general, we're kind of working at the hands of the phone developers. We have to see what kind of hardware the phone developers are going to release, and then we get to go and write software for those phones. So augmented reality and machine learning are two things that are really hot right now in mobile development. It's moving fast, and people are getting really excited about it because there's so many different ways that it can be applied to different apps. It can really rethink the way that we're using our mobile phones right now, and using even iPads, tablets, things like that. All of that stuff is changing all the time, and it's changing quickly. So with augmented reality, for those that don't know, that's when you bring up your phone and an app will show a camera feed. So you'll have your back camera facing towards the outside world, and it'll show you on your screen what's going on through the lens of the camera. But then it can also add some generated content onto that image. So it could be characters, it could be homes, it could be instructions for some kind of do-it-yourself project, and that can be placed on top of the real camera image that you're seeing from your device. So augmented reality is something that's really moving fast right now, and machine learning is moving fast right now. So machine learning is something where your camera can be taking in information from the outside world, and it can understand what's going on in the outside world based on different models that are programmed into your software. So when you combine machine learning with augmented reality, there's the possibilities are so endless, because the software can be taken in the camera feed, learning the outside world, and then generating content on top of it to generate a really immersive experience for the user. I've even heard of one example that was really cool of maybe an auto mechanic is working on a car right now, and he's not real familiar with this type of car, so he needs to understand where exactly a certain part is located underneath the car. And right now, goggles and glasses are something that are really starting to generate a lot of conversation. So maybe the auto mechanic's wearing a pair of goggles or glasses that has some augmented reality technology, and it's not only allowing the mechanic to view what's in front of him or her underneath the car, but it also projects the instructions or a diagram or something like that that can help the mechanic to locate that part or understand what it is that he or she needs to do on the car. So there's a lot of cool examples, and the possibilities are endless.
And Tom, is that compute power, is that going to be needed on the phone, or is that going to go up to the cloud and use server-based processing capability?
It's moving towards the phone. Some machine learning used to be completed on a server, and the phone would just communicate with the server to get the information it needed. But as these phones become more and more powerful, a lot of that computing power is moving to the phone.
Hey, Tom, could you take us to a moment in time of an incredible aha moment you've had at work or your personal life, and tell us a story and how you turned that aha moment into success?
So one that I had that I can think of right now is when I was an undergrad at Michigan State. I was working on a project with a few other engineers in my senior design course. And our project was working with cameras, and the camera would be plugged into an FPGA. So you're familiar with FPGAs, which for those that aren't familiar with FPGAs, it's basically a circuit. It's a chip that's on a circuit board, and that chip can be programmed to handle different inputs and generate different outputs. So we were using this FPGA to take a camera feed and try to understand what's going on in the camera feed. Our initial goal was to have some form of object detection. And the application for this project was rear view cameras inside of a car. So when you go and put your car into reverse and you're driving in reverse, and that camera feed starts to show up on your dash so that you can see if there's a bike or a pet, or even worse, your child behind your car, you can see that and stop the car. And we wanted to implement some form of object detection. Well, we spent a lot of time trying to work through some really complicated math equations, some really complicated machine learning models. And machine learning's come a long way since 2010 when I was working on this project. But at the time, with what we knew, machine learning on an FPGA was very, very difficult. And we started kind of working on one of the basic elements of object detection, which is edge detection. So edge detection will look at an image from a camera, and it'll detect all the edges in that camera image. The way it does that is it just looks at very high contrast differences from one pixel to the next. It's a little more complicated than that, but that's the way we can think about it. So we start out with edge detection, and we get edge detection on top of our normal camera image, and it looks pretty cool. We could be walking around in the camera feed, and there's lines drawn around each person. It's really neat. But like I say, the main goal here was object detection. So we were banging our heads against the wall trying to figure this out, and eventually we stumbled across an equation that would allow us to detect skin inside of a camera feed. And we all looked at each other and we said, if we can't figure out this object detection stuff in the right amount of time, what if we implement human detection? Humans are the most important object that we could detect inside of a camera feed. So let's combine the skin detection with our edge detection, and we can detect humans inside of our camera feed and project that on top of the camera image, which we ended up doing successfully. We planned it out, we came up with the equations that we needed, implemented it, and it ended up being a really successful project where we were able to show humans kind of walking around on the camera, and they would be highlighted in a different color, which I think is actually really helpful inside of a camera feed. And so this aha moment was more of, okay, here's another direction that we can take with this project, which actually happens a lot in engineering. And it led us down a different, more successful path that we were able to come up with something really cool with. And it kind of worked out really well for us.
Yeah, STEM Nation, I'll say that you got to be alert to, when you're trying to solve problems, you got to keep your mind open to all different options that are coming your way and thoughts that are coming your way. If you have a thought, write it down. You have another thought, write it down, and take a look at those the next day and see what they're telling you. You might come up with something that you never even thought about. So thanks for that, Tom. And speaking of college, it sounds like you had a large project in senior design, so your fourth year in college. But if you go back to when you were 18 years old, heading off to college, what are some things that you wish you knew back then that would help our STEMers launch into college successfully?
The one thing, I've thought about this a lot, actually, and I think the one thing that I would say that I wish I had known when I was going into undergrad is that it's so important to make sure that you understand all the concepts that you're being taught in class and that they make sense in your head. A lot of times when we're heading off to college, there's a lot of emphasis put on our GPA and our grades. And I think those are really important things. You have to have good grades. That's your ticket in the door. You got to have good grades. You got to work really hard. But you also need to focus on making sure that you understand the concepts. Really understand what's going on. Make sense of these complex things inside of your head. And if you don't understand it, you need to ask questions. You need to have a conversation with somebody. You can try teaching it to somebody else. Sometimes teaching somebody else a concept helps you explain it to yourself and really learn it. And look for other ways outside the textbook that you can apply some of the things that you're learning in class. Maybe it's a little experimentation. Maybe it's doing some more research online. But the overall theme is just find what works for you to be able to understand what's really going on in the concepts that you're learning in class and be able to cement those concepts inside your head, because those are the building blocks that you're going to use when you leave college to be able to solve really, really hard problems out in the professional world.
Yeah, I second that, Tom. It's you got to have good grades, right? You got to have grades. That's a ticket in. I absolutely agree with that. But more importantly, you have to understand the concepts. You have to understand the basics. If you don't understand those basics, you're going to have very challenging times as you progress through your engineering curriculum. And with that, Tom, we're going to take a quick pause here and thank our sponsor, Audible, who is offering a free audiobook. You can head over to STEMOnFireBook.com. That's STEMOnFireBook.com to get a free audiobook of your choosing. If you decide to cancel within 30 days, there's no cost, and you keep the audiobook. And Tom, are you ready for the lightning round?
Yeah, let's go. I'm ready.
Alrighty. What is the best piece of advice you've ever received?
I come back to this advice all the time. And when I was working in my first role as an electrical engineer, my manager saw me kind of spinning my wheels on a project. And he told me, Tom, you don't have to be an expert at everything. Go ask somebody that knows how to help you.
And what is a personal habit that contributes to your success?
I think a personal habit that contributes is just keeping an open mind and trying to learn new things all the time. Like I say, there's ways you can differentiate yourself from other engineers. And one way I try to do that is to sit down, read blogs, read technical notes, and just keep learning something new every day.
And what is your favorite internet resource or phone app and why? And it can't be realtor.com. That would be cheating.
Yeah, that's okay. I understand. So my favorite app right now, I think, is Medium. And it kind of goes back to the last question of staying on top of my field and trying to learn something new every day. Medium is an app that allows both professional and amateur writers to go and submit different blogs and technical notes into a huge collection.
All right. And what is one book you recommend and why?
A book that I read that I really enjoyed was Think Like a Freak. It's from the authors of Freakonomics. And the reason I like this one is it really helped me to think about work and my personal life in different ways. Each chapter is a new concept of how you can train your brain to think in a different pattern. One example I'll give is a chapter about making sure that you're thinking about the right problem. Sometimes we get so deep into a problem that we're working on in engineering that we forget what the original question or task was. And you have to kind of stop yourself and say, hey, am I asking the right question? Am I troubleshooting the right problem, or is this just a symptom of the underlying problem? And it kind of trains you to think in different ways like that.
All right, Tom. And as we wrap up here, can you share a parting piece of guidance for STEM Nation? And then we'll say goodbye.
Yeah, so my parting advice for STEM Nation is to find something that you love and go be the best at it. You know, when we're coming out of high school, a lot of times there's so much emphasis put on which exact career can you go into to make the most money. I remember even looking at the opening salaries for chemical engineers versus electrical engineers. And I think the opening salary for a chemical engineer was like $5,000 more or something like that per year. And that was something that I actually thought about when I was choosing my career, it's ridiculous because, you know, a really good electrical engineer is going to make more money in the first or second year even than a chemical engineer that isn't happy with his or her career choice and doesn't enjoy the work that he or she's doing. So my advice is find something that you really enjoy, that you truly enjoy, whether it's STEM or not, and go learn everything you can about it and be the best at it. That's the easiest path to success that I can think of.
Thank you for that, Tom. And with that, we will say goodbye.
Okay. All right. Thanks, Jeff. Thanks for having me.
I hope you enjoyed our discussion today with Tom. He provided tons of value. Head on over to STEMOnFire.com, subscribe to the email list to keep up with the latest happenings, and be sure to subscribe to the podcast on your favorite podcast player. And again, if you're getting value from this podcast, please share it with a friend. Tune in next week where we talk with Murthy, who is a chemical engineer. Until next time, I hope this chat has helped ignite your passion towards a STEM career.